All right, and we're off. So chapters 4, 5, and 6. Today we're just going to do chapter 4. We started a little late, so tomorrow we'll hit 5. We basically 6 we just finished doing, so we'll skim through 6, but we'll hit 5 a little bit so you can kind of remember what we were doing back then. Well, you sit and watch. It's about learning. School's not about getting a grade. I know what you're going to say. Well, it is for me. That's all I care about. Yeah, I get it. I get it. But technically, school is not about just getting a grade. School's about learning stuff. So you might learn something here. And we've probably hit some of this stuff. Even with the last chapter that we did, you might recognize some of this stuff. So yeah, it's good to pay attention. Let's not sleep. Let's just look up here, see how it goes. It says classify each triangle by the angle measure and the side length. So how many answers are we going to have for both of these? Two. We're going to have two. We're going to tell what kind of a triangle is it because of the angles. So what kind of angle does this triangle have? It's got a right angle. So what kind of a triangle is it? It's a right triangle. Easy enough, right? Now, what about the side length? What do I know about the lengths of the sides? Well, two of the sides are what? Equal, because they got these little tick marks on it. So what do we call the triangle that has two equal sides? It's one of the weird, it's isosceles. See? You do know this stuff. Isosceles triangle. That's what they're trying to do for this, okay? I'm not going to write down every single, well, I don't know, I might, but since we're only doing one test, maybe I will. So what about this? About the angles. Well, I don't know anything about the angles, do I? But I do. They're equiangular, that's right, because if three sides are equal, then all three angles are equal. And we call that equiangular. E-Q-U-I, and then angular. All right, so that's an equiangular triangle. And what if all the sides are equal to each other? What do you call that? We'll go equa again. Equal what? Lateral. That's an equilateral triangle. Or you could also, two of the sides are equal, correct? Remember what isosceles meant? It doesn't mean exactly two sides are equal. Two or more, right? At least. Good. That's the definition. At least two of the sides are equal. So if you wanted to, you could also call this isosceles. Most of the time, we wouldn't. Most of the time, if all three sides are equal, we're going to call it equilateral. Okay, but technically, yeah, you could call it isosceles. All right, enough of that. Let's take a look at this. Let's find angle A. So everybody should be able to do this. Silas, I bet you can do this one. So how do I find this angle right here? Yep, add them up. So that's what? 140. You got the right idea. You just stuck the 1 in there. You subtract it. That's right. And then what do you get? It's not 20, actually. It's what? It's 40. That's right. So that would be 40 degrees. Everybody agree? Yeah, because they all add up to what? 180.
Well, I didn't know that.
You didn't know that? You didn't know that?
I just forgot. I'd be getting confused.
Yeah, I think you did.
I thought it was 360.
360 is if you had like a four-sided figure. If you had a four-sided figure, all four angles add up to 360. Okay, but a triangle, they add up to 180. All right? ACD, where's that? ACD. It's this one right here. Here's another one that's fairly easy, and you're going to use 180 again. Look, this angle right here and this angle right here, they're next to each other. So what do they form? They form a straight line, right? How many degrees is a straight line? 180. That's right. So what am I going to do here? I'm going to go 180 what? Minus 70. That's right. And that's 110. So that angle right there is 110 degrees. So far, pretty easy, right? These two? Yeah. Now, unless you actually learn this stuff, you wouldn't know how to do this, okay? Because we didn't even mention this stuff on the last chapter. But for those who are here all year for this chapter anyway, you should know how to do it. It says, for the following pairs of triangles, write a valid congruent statement. What does that mean, congruent statement? That means triangle ABC is congruent to triangle whatever, DEF or whatever you want to call it, okay? And it says, and, so here's another double answer. You got to get them both right to get it. Name the postulate that justifies it. So let's take a look at these two triangles. I got this triangle right here and this triangle right here. Let's call this triangle something. What do you want to call it? WXY? WXY. And it would be congruent to. So if I go W, then X, then Y, what letter am I going to have to start with here? If I started with W here, what letter am I going to start with on this triangle? Well, the one with the one arc, which it starts right here. See, that's the one with the one arc. So we're going to call it Y. So if I went WXY, the X is the one without the arc. So which one doesn't have the arc here? It's Z. And of course, what's the other letter? It's got to be W. And it has to be in that order. Now, the WXY could be in a different order, right? But they have to match up. So the W and the Y have to go together. The X and the Z have to go together. And the Y and the W have to go together. So there's multiple ways you could write this answer and still get it right. Okay, but you got to make sure that those letters that I just told you, they have to be in the same spot. Okay? Everybody remembers this, right? That was here. What's the name of the postulate? So look, I've got an angle, and I got an angle. What else do I have that they didn't really mark on this picture? I got the side, this one right here. So I've got a what? Angle, side, angle. Same thing on this one. Here's this angle, here's the side, here's this angle. So it's angle, side, angle. So did you do any of that at your other school? You didn't do congruent triangles or anything like that? Okay. All right, let's take a look at this one. Yeah, I wouldn't expect you to know how to do this. Is it proofs?
It was congruent triangles, but it did not look like this at all.
It didn't have side, angle, side? Did it look more like this?
It was that, and we did a little side angle side, but I didn't.
All right, so you did do that stuff then. Right. Right. But they were doing it though.
They literally just started it.
Okay.
So I didn't know anything about it.
Yeah, that's right. I'm just seeing if they actually taught it or not. And almost every single geometry class would always teach this stuff right here. All right, so here we go. What do you want to call this one? Let's go QRT. QRT. Now, you could call this left triangle anything you want with those three letters, right? It doesn't matter what order you put them in. I just decided to go QRT. So if I go QRT on this left triangle, what am I going to go on this right triangle? QST. That's good. QST. So we got the first part. That's the congruence statement, right? Those two are congruent to each other. Now we got to do the second part. We got to name the postulate. This was just as easy as this one. But what do I have? I got two sides, and what else is not marked that I could figure out? The other side, just like we did over here. So now, why are these triangles congruent? Side, side, side. I actually put 3 here. Side, side, side. Yep. That part's actually kind of easy, isn't it? All right, knowing side, angle, side, 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 side. But you got to see what's missing. This one's probably easier than these two because you didn't have to fill in, right? You didn't have to know that that side was equal and this side was equal. You got all 3 things already for you. So let's just give me the postulate why these triangles are congruent. Side, angle, side. Yep, side, angle, side. Now let's do the congruence thing. What do you want to call this one? Yeah, definitely I'd call it ABC. So if I go ABC here, now here this is the part that's a little bit tricky, right? Well, this doesn't have a mark on A and C doesn't have a mark, right? So how do I know which one goes with what? Well, here's what I do. Do you see how this has 2 tick marks on this side? Well, A is opposite. Everybody see that? So what is opposite the side? What angle is the opposite? Let me try to say this again if I can speak right. What angle is opposite the side with 2 tick marks over here? Angle F. So if I call this A right there, then which one would go with the A? The F. How do I know that? Because the A is opposite 2 tick marks, the F is opposite 2 tick marks. So the first one's going to be F. And if I go B, this one's easy. B has got the one little arc here. Which one has the one little arc on this one? The E. So that would be E. Now there's only one other letter left. What is it? It's D, and there you go. So there's triangle ABC. Now again, the A and the F have to go together, the B and the E, and the C and the D. They have to go together. You didn't have to call this ABC. I could have called it BAC or CBA or CAB, right? You could have called it several different things, but the A and the F have to go together, B and the E, C and the D. Oh, you know what? I messed up. You said it right. I said it wrong. Where did I mess up? No. I said it right. My bad. Whew, good thing. That would have been my first mistake of the year. Just kidding. All right, yeah, I saw that angle right there, and I don't know, for some reason I was thinking angle, side, angle, but we don't know, right? We didn't know that that angle was equal to this angle. We know that side, that angle, and that side was equal to this side, this angle, and this side. So yes, side, angle, side was correct. All right, let's do another one. Here we go. This is the one that really messed people up when they took the test the first time, and the quiz that we took on this. So let's go through it. It says, state what additional information is required to know that the triangles are congruent for this given reason. All right. So what if they said angle, side, angle? Well, they only give you the one angle here, don't they? You do know the other side, though. What's another side? We already did that a couple times, the BD. So what would the other angle have to be? Because I already know that BD is equal to BD, right? But what other angle did they not tell us is equal that should be equal? ABD, that's right. This one right here. Okay, because look, there's an angle, because we're using angle, side, angle, correct? So there's an angle, there's a side. What's the one thing that's missing that we need to fill in, the additional information? We need to fill in what that other angle is right there, don't we? Because then it wouldn't be angle, side, angle, because the side has to be between the two angles. I can't just go angle, side, and this angle. You see that? So the side has to be between those two angles. So this side is between this angle and this angle. So it would be this one and what else? That one right there. So what additional information is required? Well, how do I name this? I don't just say angle B. What do I say? Angle A, B, D must be equal or congruent to, if I go ABD, what am I going to call this one? CBD. Okay? And that's the answer. That's the additional information. A lot of people struggled with this when we took the test. All right, let's do this one. Side, side, side. Well, what side do I already know? It's not marked, but I can look at it and tell you exactly the XY. That's right. So that one right there. Now, there's another thing that I don't know, but look, I want to show that they're congruent because of what? Side, side, side. Well, there's one side. There's my second side. What's my third side? WY, and what else? There's my side, side, and third side right there. So what must be equal? WY and what else? XZ or ZX. I don't really care what order you put it in. So that would be your answer right there. All right. Again, we didn't know that these were true. That's the additional information that I needed in order to say that those two triangles were congruent to each other. Okay? All right, one more of these. Now, there's something, we've done this a lot, right, where it's got that shared side. Does this have a shared side like these had a shared side? No, but they do have something else. Just looking at it without any other information, there's something that I know that's equal to each other. It's this angle and what else? That one right there. Why are they equal to each other? Just by what? They're vertical angles, and vertical angles are always equal to each other. Anytime you have two lines that intersect each other, you're always going to have a set of vertical angles, two sets actually. They're always going to be equal. That angle right there is always going to be equal to that angle there. This one here is always going to be equal to this one right there. So do we have that same situation here? Yeah, I got a line here, they intersect. These are my vertical angles, so I know they're equal. So look, I know my one side, right here. Everybody see that? I know my angle, right? I know this side is this one. I know the angle is this one. What would the other side have to be? Like on that first triangle. LK, right. LK and what else? Yeah, NK or KN, right? So it would be angle. I hate that they put an L in there because my angles and my L's kind of look the same sometimes. All right, so angle, it's not even an angle. What am I doing? So it's LK, it's a line segment, is going to equal, if I go LK, let's go NK. All right, so that would be my additional information. Right? And then they would be congruent because of side angle side, wouldn't they? So if that one was equal to that one, then they're congruent because of side angle side, what they told us to begin with. So we struggled a lot with that on the other test, but it should be something that should be kind of easy. All right, let's do this one. I'm just going to go through it really quick because I want to hit some of these other ones down here. It's kind of the same thing, but look, I even give you a choice, 4 choices of what it's going to be. Write a triangle congruent statement. So let's do the triangle congruence first. What do you want to call that first triangle? Let's go ABC again. Is that right? ABC. So if I go A, then B, then C, then what am I going to do here? Yeah, see, this angle right here is equal to this angle right there because they're alternate interior angles. So this angle and this angle have to go. All right, so I'm going to go C. And then the second one is the right angle, so the second one here has got to be D. And then what's the other one? It's A. So those triangles are congruent. Now, why are they congruent to each other? Well, I've got an angle. Well, yeah, I've got an angle right here, and I have that hypotenuse, right? So I've got a hypotenuse and I got an angle. So which one of these am I going to use? Hypotenuse angle. Okay? All right. I just got to go through these kind of quick now. This is, let's call it JKM. So triangle J, it's an ugly K. Let's try this again. KM is congruent to, so if I go JKM, it's not LMK. Is that what you said? If I go J, then K, then M, I'm going to go L, then K, then M. You see that? Because I probably just missed it. I don't know. Did you write this JKM? Yeah, I must have missed it then. Okay, yeah. So if you wrote that, see, it doesn't have to be in this exact order, right? If you wrote JKM in a different order, then this would be in a different order. You just have to have the J and the L, the K and the K, and the M and the M match up. That's it. All right. So what do we have? I got this, don't I? Yeah, so I've got a leg already, and I got a hypotenuse, and look, that's it right there, hypotenuse leg. All right, and one more. What do I know? I know the vertical angles are equal. Okay, and so look what I have. I've got a leg, and I've got an angle. All right, and so it's leg angle. That's right. And you can do the triangle thing. We're running out of time. I need to move on because I still got up to 20. All right. So what do we know about this? Look, this is a mid-segment. On a triangle, the mid-segment is what of this right here? It's half of it. Or the side opposite is twice as big as this. So if this is 7, then what's XZ? It's got to be 14. All right? So when it hits the midpoints of both sides, the mid-segment's half of the third side. Or the third side is twice as big as the mid-segment. Same thing here. If this is 24, what's VU? It's 12. Super easy. Okay? This one's a little more difficult, right? But we could write it like this. We could say that 3x minus 8, this one is how much more of this one? 2 times. That's right. So it's 2 times x plus 2. And now you can do the math and you can solve for x, plug it back in. Okay? Can you do this? Can you do this? You should be able to. What's this? 2x plus 4. Subtract a 2x from both sides. That gives us an x. Add an 8 to both sides. That gives us a 12. It's not my answer, though, is it? What's my answer? I got to find yz, so I got to plug it into that. So 12 plus 2 is 14. So that's how you get that. We good? I am recording, yes. All right. Here's something we got to remember. The slope. The slope is what? It's the change in y over the change in x. That's something you have to memorize. That is super important in order to get this problem right. So let's look at BC. Where's BC? Hold up. On my answer key, I don't have BC written down. I have AB. What did I do? Did I mess that up? You have your test, Jamarian? Does it say BC and DE on there? Or does it says AB? This should be AB. 17. This should be AB. Because I actually, yeah. And what's 18? AB? All right, yeah, so it is AB and DE. What I did is I couldn't find, long story, but I couldn't find this chapter test, and I had to rewrite it again, and I think anyway, let's just do this, AB and DE. So let's find the slope of this thing right here. How do I find the slope? We're just going to do one of them because the other one's exactly the same. All right, so how do I find the slope of AB? Well, what do? I subtract the y's from each other, so let's subtract them. 5 minus negative 1, and then subtract the x's from each other. 6 minus negative 4. 6 minus negative 4. 5 minus negative 1 is 6, and then 6 minus negative 4 is 10. Reduce it. What is it? 3/5. So the slope of this is 3/5. Look at DE. What's true about the slope of this line and the slope of this line? The mid-segment. What does it look like? No, not slope. We're not finding the distance. Okay? They're the same. The slope, they have the same slant, don't they? They have the same exact slant. So DE is going to be the same exact thing. All right, one more and we're done. We've got 1 minute to do this. This is the distance formula. Do you remember distance formula? Again, I put DC. I shouldn't have put DC, should I? I should have put DE and AB. I think on your test, it's right. It's just on my thing that I wrote is wrong. All right, so let's find the distance. Let's write it down. I don't know if you still have this memorized or not. Do you remember the distance formula? Put your parentheses in your squared. Put a plus. So it's what? X minus X, right? Or X1 minus X2, and then Y minus Y. Y1 minus Y2. Okay? And then we're going to take this. So let's take this and apply it. So big old square root. I'm going to put my parentheses in squared plus parentheses in squared. Subtract the x's. So 6 minus negative 4. Let's do it in our head. We already did it up here, right? What's 6 minus negative 4? It's 10. Let's do the y's. 5 minus negative 1. I already did it up here. What's 5 minus negative 1? 6. What's this? 100 plus what? 36. And so it's the square root of 136. I would be perfectly fine if you left it like that. That can simplify, but that's an algebra situation. Just leave it like that and you're done. Wow, look at that. Good timing. We finished. Chapter, what was this? Chapter 4. Okay, so there you go. We'll do 5 and 6 tomorrow.